Okay, now we know the logic of identifying a causal relationship between two variables. But it sounds like if we need to go through all three ladders of causation, especially the third ladder, we might need a time machine, or we might need some kind of technique can help us to travel from one universe to another parallel universe, right? But we don't have a time machine. At least we didn't see that in our reality. And there's no way for us to travel from one universe to the other. So what can we do? Actually, in reality, we can do that, but we make some compromise. It is widely used in medical field about how we can understand the causal effect of one medicine on some kind of disease. Now, here the example is how do we know the effect of vaccine on the COVID-19 infection rate? How do we know that? We have an assumption, and assumption is very clear that we understand and we assume that a vaccine can actually reduce the infection rate of COVID-19, but how do we do that? And the answer is through randomized experiment. So medical experiments are mostly randomized experiments. It is very important to notice that not all experiments are randomized experiment. There are some other kind of social experiments you can find on YouTube channels. There are experiments in which people intervene in the real world and see how other people react to the intervention. So these experiments have some feature with the randomized experiment. However, these are not randomized experiment, and therefore the conclusion from these experiments might not be causations. It's just observed. There's just some observations. So what is randomization here, and why randomization is so important? The essence of random experiment is the random assignment of participants, if there's any, in the experiment. It is a process that scholars randomly deliver or assign experiment participants into different groups. And the goal of random assignment is to create counterfactuals, which is the third ladder of the causation. Well, in this situation, in a very simple setting of a randomized experiment, we might have a treatment group where people will accept the intervention, like take the medicine or take the vaccine. And there's a control group. Well, they will take a placebo treatment or they will get nothing, right? So other than that, everything will be the same. So the treatment ensure the exogenous intervention, that which is the second level of the causation. And the random assignment achieve the goal of creating or simulating the condition of a counterfactual. Because by this kind of random assignment, people do not select to be people do not self-select to be in a treatment group or control group. The assignment here is not relevant to any factors of those people. It is just pure random, which is maybe through flipping a coin or generating a series of random number for everyone in the experiment. So when people are randomly assigned into different groups, they are not perfectly equivalent to each other, but they are statistically equivalent, which means these two groups have similar, for example, gender proportion, racial structure, and other observable or non-observable features. So on average, they are the same. It is not magic. So it is actually one thing that we need to discuss further when we talk about sampling. Maybe we can discuss that later on. But remember, the random assignment will lead to the control group and treatment group, which are statistically equivalent. So that we can, by comparing the outcome from the treatment group and control group, we can estimate the average treatment effect of our intervention. Remember, it's an average treatment effect. Some people may be influenced more severely than others, or some treatment may have weaker effect on some other people, which is not shown in the general comparison where we only take two groups for the comparison. We need to do additional work to consider why and whether there's any kind of different treatment effect among different group of people, and that is where we need to consider the moderator. But most importantly here is the random assignment will lead to two groups or more than two groups, which are counterfactuals, okay, which are statistically equivalent to each other. So here is an example of a typical randomized experiment in psychological research. So on Canvas, there's a paper talking about power posing and people's confidence. It's a very famous study by Amy Cuddy, and still it is top TED Talk video on their website. So it argues that if you can posing in an open gesture, like Wonder Woman, you can actually feel more confident after that. So this is how your behavior influence your psychological status, your mental status, which is fascinating because we always assume that it is our psychological status that lead to our behavior. But now we can see here is something opposite. We can actually do something to change our mind or to change our mental status. So how do we do that? How do we find that? The thing here is they use a very simple design, which is a randomized experiment in the lab. So they recruit a bunch of students, college students, and they are assigned into different groups. One is a treatment group where people are requested to use a high power posing like this. And in a control group, students are required to do a low power posing in a more closing gesture. After holding this posing for 1 or 2 minutes, they receive a survey, which is used to measure the outcome, which is the perceived confidence. And then they just make a simple statistical analysis, which is to compare the outcome from the treatment group and the control group. The results shows that people in the treatment group who are required to hold a high power posing for 1 minute shows a much higher level of confidence than those in the control group who performed a low power posing. And this result is causal because of the feature of randomized experiment. People are randomly assigned in different groups so that the treatment group is statistically equivalent to the control group, no matter, you may say, other variables may influence people's perceived confidence, right? For example, male are usually more confident than female, and people have higher education degree may perceive themselves more confident than people who have lower socioeconomic status. Those are all important factors or confounders that will influence our understanding of the real effect of power posing on perceived confidence. So using the random assignment can help us to isolate all those effects. We just take that as a given. No matter if it's observable or non-observable, we admit that. However, the comparison between those two groups can cancel these noises out, which allow us to only look at the intervention, which is the high power posing versus the low power posing. So this study is very interesting, right? This is something we observe in the lab. There are a lot of problems with such kind of study, and it's a shared. This is actually a shared limitation of most lab experiments. So there are a lot of settings, different kind of settings for randomized experiments. They all have pros and cons. The typical randomized experiment usually happen in labs, usually in university labs. So in the lab, you can do a lot of things. You can ask people to do this, to do that. However, the cost of managing a lab will be pretty high. And that also means because of the high cost, you can only involve a relatively small group of people in the lab. So the problem here is, since you just take a very specific group of people in the lab, the result from the lab experiment might not be applied to the reality, to somewhere out of the lab, to somewhere out of the university, right? So this is one of the major problems of lab experiments, because the setting is too clean, setting is too clear, there's no noise, everything's under control. It is not a even close simulation of the real world situation. So it's very possible that what we observe in the lab might not be replicable in the real world. For example, you can try to hold a power posing, or you can try to ask your friend to hold a power posing and then ask them whether you feel you are confident, more confident or not. It might not help because there are other factors in the real world not under control that will also influence their perceived confidence in their mind. So this is the major cost or the major shortage of lab experiment. But lab experiment is good. It's also because we have a lot of control on that, so that we can actually do our best to isolate the causal effect of our intervention. And because of such kind of criticism against lab experiment, scholars are trying to move the lab into the field, into the real world. So there's a growing development of field experiment. They are taking place in real world settings, like in schools, in companies, in public organizations, in communities, in neighborhood, all these kind of things. So in this case, there's no strict control on other factors, but they just take the field, the real world, as a lab. So this is very similar to the idea of program evaluation, especially pilot program evaluation. If you have some idea, which is a new program, which is not existing, so you can actually design that and pilot that in the field. You involve some part of people, but not others, to see what's the real effect of this program if I apply that into real world setting. It's getting more and more popular. It's a very important policymaking tool these days. And but the problem is the cost is pretty high, and a lot of things are not under control. So that the estimation will take a lot of time and effort, so that we can estimate the real effect in a more accurate way. Another more generalizable experiment is called survey experiment. Survey experiment is not, sometimes it's similar to lab experiment, especially survey experiment is usually embedded in survey questionnaire. So maybe you can play some game in the survey. You can give people one vignette or one story, and you manipulate some part of the story, and then you ask people certain questions. And you assign people into different stories to see how people react differently to some different narratives, for example. So in this way, the cost of such kind of experiment is relatively low. And compared to a lab experiment, sending out survey is much more cheaper, so that you can hire more participants for a survey experiment than what you can do in the lab, so that results from a survey experiment can be more generalizable, right? So in this case, survey experiment is also quite popular. However, you cannot do everything through a survey, right? You cannot ask people to post in a high power way. You have no control on whether people do that or not. So that's another problem with survey experiment. And we can discuss that later on if you really want to run a survey experiment. It's quite useful. It's quite cost friendly, but it also has severe limitation. So here is an example of a field experiment. Some part of these look like a qualitative study, but actually this is a quantitative study. So the goal of this experiment, global, it's a global experiment. It happens, it took place in different field in the world. So the goal for their study is to find out whether people's honesty or pro-social behavior is related to the value of the economic value of the product or of the goods that of the interest. So, or whether people are motivated by any kind of economic value to perform, to be honest, or to perform pro-socially. So what they do is they just throw more than 10,000 wallets in public spaces in different countries and different cities, and they observe what's going on. So they actually they observe how many people actually turn that back to lost and found in those area, and those staff members at lost and found actually contact with the person um, who presumably lost a wallet in a public space. So this is this is a fascinating study. And what they do is they manipulate what's in the wallet so that people know the value of the wallet. And a competing theory here is the value of the wallet may make people more or less likely to return this wallet, right? So if they see this wallet is very valuable, for example, there's a lot of money in that, maybe they feel like, okay, the owner of the wallet might be very worried about that, so they are more likely to return that. If the wallet looks valueless, they might think, okay, it's not very urgent, so they might not do that. So in order to control the situation, they make a transparent wallet where people can actually see what's in it. And there's a name card in the business card in a wallet, so that people who got this wallet at the public space or the lost and found staff member can actually contact with the person, Michael Wilson. Sounds like a rich people, software engineer. But actually, the email address here is the email address of those scholars. So they create those hypothetical or fictional email address, and they can actually receive email from that so that they can collect the data. So they manipulate what's in the wallet. They put money, or sometimes they put a key in that, and they create a counterfactual through manipulating what's in the wallet, so that they can compare when the value of the wallet change, to what extent people will return this wallet to the public space. So this is a pretty fascinating study in the field. It's a very large scale. It can be very expensive because you need different research team in different area, and you need to pay the salary, you need to spend a lot of time for design, and you might need to coordinate with the organization in that field so that you can do that. Okay, so that's one example of a field experiment. Field experiment also contribute to important issue in our society. For example, anti-poverty issue. In 2019, the Nobel Prize of Economics reward to an important team from Harvard University on their contribution of finding out what kind of foreign aid can actually help to address poverty issue in Africa. So there's a TED Talk I post on Canvas, so you can see that what they have done and how things have been conducted. And there's also a very important book from this team, which tells you how to run a program evaluation using field experiment. So if you really want to pilot some program, just don't throw that to everyone in the world, in the field. A better way to do that is to randomly assign people into different conditions so that you can compare, you can isolate the real effect of the program. And that will be a very valid evidence which shows the effect of the program. Okay, so that is why randomized experiment is considered as a golden standard of causal identification, because it creates, through random assignment, it creates counterfactuals by which we can compare, through comparison between different groups, we can see the real effect of the intervention. And this is something we cannot do by only observing the real world or how the real world is happening. Okay. However, it's not all questions can be addressed by randomized experiment, because sometimes you will find it is unethical to assign people in some group versus the other. And sometimes you just cannot manipulate like how the organization is going to do, right? You cannot do that. So in reality, it's another kind of challenge. There's so many questions we can just observe. There's no way for us to run a randomized experiment. But still, there are important strategies that can help us to estimate the causal relationship between two variables. And next week, we're going to go over these strategies. And remember, you don't need to understand all of those strategies, but the most important feature that's shared by those strategies is that they are all trying to simulate the randomized experiment. They are all trying to create counterfactuals in their unique way, but they always need to go over all three ladders of causation. So what you learned here today is a very important foundation for you to design an analytical strategy for your program evaluation. So I would suggest you to go over this lecture again and again, and we can always talk, okay? So here is the end of the lecture, and now it is your time to practice designing a randomized experiment on Canvas. I'll see you all next week.